In the last video, the first thing that we're going to do is go over an example for finding extrema. And these are kind of the 4 steps that you do in doing that. Make sure those are written down in your notes. So looking at this function, first thing we need to do is figure out the critical points, right? Now, number 1, these are critical points. So at x equals 1 and 2, those are critical points. Those are our first 2 critical points. Now to find other ones, we're going to find the derivative and set it equal to 0. Go ahead and pause the video, find the derivative, set it equal to 0 to find your other critical points. Okay, so when you do that, you get x equals 0 and 1, setting that first derivative equal to 0. Now we have 4 critical points. We have 0, 1, -1, and 2. Now what we're going to do is we have to find the values of each one of those, and that's step 3 above, I believe. Steps 2 and 3, finding the values of both the critical points and your endpoints. Right, so what I like to do is put them in order. So you have your lowest, which is -1. That's your lowest x value. Figure out what that is. Then you have 0. Then you have 1. Then you have 2. Go ahead and evaluate each one of those critical points into your original function. So you would be plugging it back into here to figure out what those y values are. Pause the video and then come back. When you do that, you get these values. You get 7, 0, -1, and 16. Then we can easily identify the max and the min. This is the lowest right here, so that's your minimum. And then this is the highest, and so that's your maximum. So the minimum occurs at 1, -1, and the maximum occurs at 2, 16. Right, so really, if it asks where does it occur, you want the coordinates is probably the best. If they want to ask what is the value of the value of the minimum is at -1 and it occurs at 1. The value of the maximum is 16 and it occurs at 2. Another one, finding the extrema. We already have 2 critical points because they give us the endpoints. Now find any other possible critical points. And then when you're doing this one, I want you to remember a critical point can occur both when the derivative is 0 and when the derivative doesn't exist, right? Where it creates a vertical tangent. So keep that in mind. So pause the video, try this one on your own, and then come back when you're finished to check, see how you did. When we go through and we find the derivative, set it equal to 0, you get something that looks like this. So you can stop here and interpret all that you need. First of all, there's a vertical tangent at x equals 0, okay? Because you can't plug 0 into the denominator. And then also, when you plug 1 in there, that's a solution. It makes it true. So now we have our critical points. There are 4 critical points that we were able to identify. Those critical points are -1, 0, 1, and 3, because -1 and 3 are your endpoints. Now we evaluate the y values at each one of those points. Go ahead and pause the video and do that. And when you're finished evaluating the y values out of the original function, so use the original, come back to the video. So when we evaluate those, we find that our minimum occurs at -1. Your y value is -5, and our maximum occurs at 0 when your y value is 0. Now let's look at another example. Go ahead and try this example doing the exact same thing. We have these 2 critical points already because they're endpoints. Find the derivative and set that equal to 0. You will need to, in order to be able to solve this without a calculator. You're also welcome to use a calculator if that's allowed. But in order to solve this without a calculator, you will need to know that sine of 2x is the same as 2 cosine x sine x. All right, so you'll need that trigonometric identity in order to solve this. Okay, so here we have the derivative is 2 cosine x plus 2 sine 2x. Set that equals 0. Now you could punch this into your calculator to figure out your zeros, which is just fine, or you can use that trigonometric identity for the sine of 2x. And so then when we do that, we plug in 2 cosine x sine x for the sine of 2x. That gives us 4, use my rainbow, 4 cosine x sine x, and then each of them have a 2 cosine x, so we take that out. Now we can set them both equal to 0. So we set 2 cosine x and 1 plus 2 sine x equal to 0. Go through and solve. You could divide by 2 here, but you get pi over 2, 3 pi over 2, and again, I think I have my unit circle over here. There it is. These are all with the unit circle, right? Where cosine, remember cosine is your x values are 0, pi over 2, 3 pi over 2. And then here with your sine, you're looking for the sine of x. So 1 plus 2 sine of x, subtract the 1, divide by 2. You get the sine of x is equal to negative 1/2. And again, look at your unit circle, right? Where the sine, which is your y value, is negative 1/2. That's going to be in your lower 2 quadrants. That's going to be right here at 7 pi over 6 and right here at 11 pi over 6. That's where those values come from. And if you did this on a calculator, it would give you decimals, which is why these are better, because we have our critical points. We have 1, 2, 3, 4, 5, 6 critical points we've identified. Now go through and find all of the y values at those critical points. Go ahead and do that. Use that to determine your maxes and mins, and then come back to the video. So these do require a little bit of work, but because there's 6 of them, there's so many. And remember, you're plugging these back into the original, so back in up here, to find what your y values are. In the unit circle, having the unit circle with you will make it a lot easier. So when we look at these, we can easily identify our maximum value is at pi over 2, 3. That is our max. And then in this case, there's a tie for minimums. 7 pi over 6 has a value of negative 3 over 2. And so does 11 pi over, that's not 2, but that's 6. That's 6. 11 pi over 6 also has a value of negative 3 over 2. So in that case, there are 2 minimums on that graph. So that is it for relative extrema, going through finding the max, the mins, more importantly, the critical points, and then using those critical points and the y values at those critical points to determine if they are maxes or mins.